Welcome to Stay Sharp in Digital Engineering, your insider's edge on all things digital in the world of engineering, products, and manufacturing. In this episode, Jonathan Scott and I continue to unpack digital twins. This time, it's software digital twins. We look at their definitions, its applications, and its role in standalone and integrated systems. We explore configuration management, DevOps, and emulating physical systems, and spotlighting a twin's impact on software reliability. Let's dive in.
Welcome back, everybody, to Stay Sharp in Digital Engineering with Razorleaf. I'm Julianne Grant. I'm one of your colleagues and co-hosts on this podcast, and along with my other co-host, Jonathan Scott.
Hello, everybody.
Hey, Jonathan. Always good to be together again to talk about digital engineering topics.
It's good times. Always good times.
It is. So today we are talking about, we're actually continuing our digital twin series. And the last episode that we did, the digital twin discussion, was on hardware and digital twins and what it relates to hardware, configuration management, ECAD, MCAD, and all those interesting topics. So today we're going to pivot and talk about software and software digital twins.
I love it. I do. I think it's a fun topic because it's at least in a lot of the circles I run around in, when people talk about digital twin, their focus is primarily on the digital representation of the physical product and the thing we did in that other episode. And this topic just doesn't get enough discussion, and we don't pay enough attention to it to see, well, what can we learn across the two areas, and what does it mean to a total digital twin?
Right, and you can see the growing importance of it. I mean, there isn't anything that doesn't have software in it, it feels, lately. I mean, except maybe this mug doesn't have software in it.
Give it a minute, it
will.
But
if it had a temperature gauge on it, it might.
That's right. That gets us into the whole IoT thing. But you're right, everything's getting sensors, controllers, whatever. It's, computing's cheap. You can do it at small scale and all those things. And so it's showing up everywhere.
Yeah, absolutely. Well, I know I like my heated gear and things like that when I'm on the motorcycle. Right. So I definitely don't mind the integration of software and technology into everyday things. So, although
I appreciate the fact that my refrigerator still does not have a web browser on it. But
I was going to say, I did buy a refrigerator that did not have feedback mechanism in it. But
I don't need to hear my refrigerator saying, "Step away. You don't need to be here." Yeah, I don't need that.
Right. Well, let's talk a little bit about software digital twins. So, can you help define it a little bit first? I think that would be helpful to set lay the groundwork for that.
Boy, I can try.
I know.
I don't know if I can define it exactly, because this is a little bit of a meta conversation, right? Because you're talking about software dealing with software. So let's start there. Digital twins that we've talked about in previous episode are representative of some other thing, right? There's the thing you're interested in, the product, and then there's the digital twin of the product, which is a digital representation of that. Well, what do you do when the product is digital? That's where it gets a little weird, right?
Yes. It's a little soft.
We've all acknowledged that now. Okay. Well, what does that mean? It means it's a representation. It's in my view, right? Now, it also gets a little strange when we talked in the episode introducing this whole series about virtual twins, digital shadows, digital twins, digital surrogates, the idea that the digital twin might control the product itself. Well, when they're both digital and they're both software, and software controls other software, some of the concept starts to fall apart, and it's weird.
It's a little gray.
It does. So, let's just acknowledge that from the start. But I think what is it? They could have different purposes, right? So you might be creating a digital twin of software for monitoring, so that you want to know, okay, when this happens, this is what's going on in the software. Maybe for some kind of optimization. It's when software starts to behave on its own, maybe in complex or unexpected ways. You want to watch it, observe it, optimize it, that kind of thing. I think it's there for other purposes like testing, validation. A version of a digital twin is, hey, create a build of the code, run it through, run some automated tests, and see how it does. Does it respond in the ways that you want it to? It could be things
and
that
I don't think people do that enough these days.
Well, there's the hard part, right? Is the testing is tricky. The more, it again depends on how people's philosophy and how they develop software. If you make the test as you make the software, it's a little easier, and you can automate those.
Iterative and incremental.
Yeah, and if you could do enough design and planning, and you think about the tests as you're doing the design, I think people can be better at that. But you're right, a lot of people aren't. It's get it out quickly, we'll test it later, and then you get what you're describing. I don't think people do quite enough testing. But the other twins, right? You could, here's an example, and I'm going to use the twin concept loosely, but training or simulation for software, right?
Yeah.
We see this in our business. I can't remember the name of the software, but there's like a demo software out there that lets you pre-record the software you're trying to demonstrate, and then you kind of run that version inside this simulation software. So somebody can, say, for example, learn how to click around Word, right? So it's like it records Word doing its thing so that it can play it back in a demo environment where you don't actually have to have Word installed, but you can kind of pretend you're interacting with it and learn and train yourself or demo or whatever. It's a twin, right? It's a representation of the real software. So
I can see the application of that. That one makes a lot of sense.
But the bad news is, I think I talked around your question, right? What is a digital twin of software? Could be a lot of things.
Well, that's just it. I mean, it's a lot of different applications of why you might need a replication of the software for whatever purposes are the focus. So,
and I think that you get into an interesting point by bringing that up, and that is there are some different categories, I think, of software that lead to different ways to look at what is a digital twin of the software. And maybe another way of saying that is there's times when software is the product, right? Like, I'll take an example like Microsoft Word. We think about that software as it is the product. It's what gets sold. It's the software that runs on a PC or a Mac or a phone. And the point of it is that I type things into the keyboard and I click places on the mouse and I get an output that's digital. And maybe I could print it to paper or whatever, but the output is a document with some layout, some formatting, some content, some whatever. But that's the product. There's no physical part of the product. And so I'm contrasting that to, let's take our refrigerator example. A refrigerator is the product, and the job it does is it makes things cold, right? It consumes power to make things change temperature. Great. And it might use software along the way, right? Software might be a component of that product, in addition to all the compressors and Freon and insulation, et cetera. But that category of software that goes into that product is a little different than the category of software that is Word, where...
Well, in the category of software that we're in, it seems like we're just, in that example of just software, you're trying to drive a set of behaviors or actions or, feedbacks of what you're doing with the keyboard. So
when you break it down, that's what those products are, right? They're like behavior machines. When I do this, it does that. When I do this, it does that. And at the end of the day, I give some inputs of clicking on the keyboard or, dictation or whatever it is. And the output is, it did some things to it. It massaged my inputs into an output. But those things are, I don't know, this is probably the engineering side of me is failing. This starts to get touchy-feely.
Ouch.
Ouch. But they're concepts, right? That's what the outputs are. But to your point, what is the software doing? It's behavior. Right. It's pre-programmed, expected, anticipated behavior that it does in reaction to inputs we give it.
So you kind of referred to a couple of types. I don't know if we can go a little bit deeper on these concepts. So
Yeah.
you kind of indicated like software in and of itself, software for software,
Right.
and then software that's plugged into something else, basically
Right.
to operate on a hardware or something like that.
And I put it in those two buckets, but they're probably not buckets. It's a spectrum, right? Because to your point, like software for software's sake, like Word or a search engine or a browser or any of those things, they are not entirely devoid of a physical product. It's just the product that is Word it runs on hardware. It has to have hardware, right? So that's why it's not entirely devoid of it. But the fact is, you're buying it completely separately from the hardware. But like I said, it's a spectrum because it's not totally disconnected. The Word that you buy that runs on PC is a little different. The Word that you buy that runs on Mac, and it's a little different than the Word that runs on my Android phone or my iPhone. So yeah, it's never totally disconnected.
Yeah, but on the digital engineering side, like where does the twins fit? In the software piece, Word's not a critical. It is a critical application for business,
Right.
of course, but it's not in the same order of magnitude as operating a plane. So
Right.
So, I can imagine where some software digital twins would be important there. But to me, there's got to be even a bigger breakdown in there. There must be different parts of that.
In terms of, what do you mean? Like breakdown of when...
we talked about DevOps. We talked about, things like that. Like for software's sake in the digital twin, like what kind of twins, where do the twins live?
Yeah, that's a great question. So, where do they live? And those two buckets maybe are helpful to talk about that. So let's keep in mind, it's a spectrum.
Yes.
So, but let's simplify it and treat it as two buckets. On the software for software's sake, DevOps is a great sort of connection point to that. Where does the digital twin live? So let's talk through that for a minute. When we were talking about the hardware episode, we talked about PDM and what are the parts of PDM that you need to have the right digital models to feed your digital twin. All right, let's talk about the same thing, but on the software side, from the perspective of ALM, application lifecycle management, and
we haven't
DevOps.
touched on that. Yep. Okay, great.
Right? And those are two systems or types of systems. And I will say there's a pretty blurry line between those. There's some distinctions I'll draw in a minute, but let's just talk about those two. So my definition of ALM, simple working definition, is it's where you're going to develop your software, right? You're going to capture the requirements, the things that define what it needs to do, and hopefully you're going to capture the software that you write, so you type it out and you create code and that kind of thing. And you may also capture what's compiled at the end. So you take that code, you run it through a compiler, you get some executable back that could actually be run on hardware itself. And those are all the things you're keeping in ALM. A lot of other stuff too, but that's the idea, right? From need to the design to the actual product, the executable. Okay, what is DevOps? Okay, so DevOps systems, and I'm meaning things like GitLab, which might be ALM and DevOps together, GitHub, and I'm not going to name other ones because I'm no expert in that space. But the idea is those systems are doing some of that ALM, maybe not all of it, but the pieces that get you to, I've got code and I need to compile it. But then what they're doing, the ops part, is they're then letting you automate getting it into an operational state and do things like test it. So let me give an example for those that aren't familiar with this. So if you work in the coding space and you know DevOps, I apologize because I'm going to simplify this and I'm probably going to get some things wrong. But let's just take a cycle as a description. You write the code, you tell it go, and the DevOps system, because you've configured all these things I'm going to talk about, it goes off to the hardware pool that you have that's maybe on the cloud, maybe it's in your data center. It's going to spin up a virtual machine. It's going to do a bunch of tasks to do that, right? It's a Windows virtual machine. Oh, it's an Android virtual machine. It's whatever type it is. But it's going to go create that's going to be the environment you're going to run your digital twin in, right? So that's the connection here. And then it's going to take your code. It's going to compile exactly the version you need using configuration management principles. We'll come back to that later. Compile that code and then put it in place on that virtual machine that it made. and then it's going to run tests against it. And oh, by the way, it might do this on 3, 4, 5, 10, 50 virtual machines. One for Android, one for iOS, one for Word, one for Mac, one for PC, whatever. So all these different environments or twins that it needs to run, and then it's going to run the tests. Hopefully, tests that were defined ahead of time, automated tests. So it's going to give it some input. It's going to check the output. It's going to give it some more input, check the output, and on and on and on until it comes back with feedback that maybe is as simple as pass or fail. And if it's pass, it could even go a step further, which is, all right, the digital twin checked out. I'm going to go ahead and put it into production. I'm going to launch the product. So DevOps can do a whole lot more in this process. So I think we were talking about what's ALM and DevOps and how does it fit into this, but to get to your question about, so where does a digital twin run? And if it's software for software's sake, I think the answer is it can run in a DevOps system, a DevOps environment.
But that's not the main purpose of DevOps, right? So like the main purpose of DevOps is really to do that level of iterative testing and development. But are there software packages just for software digital twins that would work with one of those systems? Or is it more just, they become extensions of a DevOps just by the nature of that
That's
software?
an interesting question. If you get down into those details, they're probably
I'm sure there's software
people
out there.
Yeah.
It's going to be.
If you can imagine the need, I'm sure software exists. There are probably software people out there who would, be able to explain this and get right into the weeds on this. I think there are software tools that act as that digital twin environment.
Okay.
And the language is probably going to fail me here a little bit. I'm going to use the term I know, which is an emulator, right? That's probably the best thing I can think of that describes a digital twin runtime environment, a place where they run, right? So I'll give you my example of that. This is going to date me, right? But when I was young, I played video games on consoles, Nintendos and Ataris and stuff like that. Well, somebody figured out that, old guys like me really appreciate the retro thing and like playing those old video games, but you don't have that hardware anymore. So they wrote emulators. So in a web browser, I can go to a website and it's running code that acts like the physical hardware that was an Atari or was a Nintendo. And they've also got the ROMs, the games themselves, right? Those products, right? So software products that you can then run on the emulator. So what am I doing? I'm running a digital twin. I'm not actually running it's a digital twin of the console, of all the hardware that was in that console. And then I'm running the actual software product, which was the software that went on the cartridge that went in the console. But I'm running that software product on this emulator, not on the original hardware, because it's making my PC behave like the hardware that was in the old Nintendo console. So if all of that has your head all screwed up, I understand. But that...
I might need more coffee, but...
Yeah. So I think an emulator is, right?
Yes.
That's the digital twin operating environment. And in some ways, that's what the cloud is today, right? So for these DevOps environments where I want to run software that's going to run on a PC, instead of actually getting a PC and installing this, new provisional build of Word where I got this new feature added into it, I run it through this DevOps pipeline. And in that process, the DevOps system says, I'm going to go spin up a virtual machine and it's going to emulate the physical machine. And that's my digital twin operating environment. But we should switch to the other bucket.
Yeah, let's
right?
switch to the other bucket. Because my nature is to think software plugs into something usually, right? Or it connects with some sort of chip or something. So,
and who knows how big the two buckets are in terms of size, right? Or that spectrum. But I think there is a lot of software component of a physical product, and that digital twin is also interesting. It's a different animal, but we can learn some things from what we just talked about for the software as software's sake piece. So let's take the refrigerator example. So you're building a physical refrigerator, but from our other episode talking about hardware components, maybe you don't have it yet. You haven't made one, but you know all the design of it. How are you going to check out the software? Because a minute ago in the software for software's sake, it's all about human input and then the computer output and feedback to the human and interfaces and stuff like that. But there was no real physical interaction. Yes, there was. It had to run on a PC. I don't mean that, right? It had to give output to the screen. But in my, simplified view of the world, it was just interacting. It was all logical. Whereas the refrigerator, it's going to control something physical. It's going to open a solenoid valve and it's going to let refrigerant go through so that the temperature drops and it runs its refrigeration cycle. And so the refrigerator gets colder inside. Or it's going to close that valve and it's going to stop that process. Or it's going to run a motor for a fan. But that software is going to control physical actions in the world. How do you do that, right? So a minute ago when we talked about DevOps and that digital twin, it could all be automated. So in the digital twin that's a mixed hardware, software kind of product, then you have to think about, we've got to emulate maybe both pieces and how those pieces work together. That's where it gets really interesting. So can we learn something from the DevOps world? Yeah, we probably can and should, about you need to spin up some kind of emulation of the physical hardware, and you need to figure out the emulation of the software that controls it and how you get that on there, right? This is where we get into interesting topics about software in the loop, hardware in the loop, different types of twins where you're incorporating certain pieces physically and certain pieces digitally.
Okay. I mean, I think about, my car starter, right? So I hit the button, the car starts. I like that.
Right.
But all the activity that has to happen for those signalings and that software to trigger, right? So the chip or whatever's in there to instruct the car to do those actions. I imagine.
Well, it's interesting. It comes back to when you say that, it makes me think, what's the difference to when we used to just put the key in, turn the ignition, and some mechanical things were happening. And still some electrical things too, right? But they were sending electrical signals over a wire, voltages, and the logic behind does it send the signal or not was something mechanical, right? It's like, all right, if you didn't get the key all the way in, it wouldn't turn. If you didn't turn it, then it wouldn't send the signal. It all felt very mechanical. But now it's, like you said, it's a push button. Okay, so all that logic is happening in software. And this is where that hardware-software interface comes in, that we got to check both, right? Because what is it checking? It's checking stuff like, is your foot on the brake? Is the car in park? All those things used to be checked mechanically, but we figured out better ways, either safer ways, cheaper ways to do those checks and moved them to software and said, if we move it over there, it's reprogrammable. We can change it over time, right? It's easier to manipulate and update and that kind of thing. But it has this impact that now you have to think about how the mechanical and the hardware, or not mechanical, the hardware and the software interact to get you the results you want.
Yeah, and that brings me kind of full circle back to configuration management. You discussed that earlier. I don't know if that's where this comes into play, but it would seem that on a build for something like that, you'd need to have all those things configured.
You got to have the right versions, right? That's
right.
And it's, in some ways, it makes life better and easier. In other ways, boy, did it make things more complex. So I mentioned a second ago, well, when we decided our ignition didn't need to be all hardware and electrical and mechanical components, but we could do that. We could do all those checks with software. Great, because it does mean we're more flexible. We could upgrade things. What that means, though, is we've got now versions of that also. It used to be just a version of the mechanical and electrical components in the ignition switch. And if you did your hardware CM, like we talked about in the other episode, you'd know which versions to test and check And okay, that's all good. But now we've got configuration management we need to do on the software side, which says, all right, I found a little problem, so I updated it. Now, am I using that version of the code or the old version of the code? Which am I checking? And by the way, when the car is ready to ship, did I get the right version of the code to go with the right version of the hardware that got manufactured and put in the car that day? So it got more complex because you have to do CM across the two, and you have to do the software CM. You have to do that well also. And that's a different animal, right? So that's another piece for people to think about in software digital twins. Software CM looks different than hardware CM. A lot of people would argue it's easier, it's better, it's cleaner. I think there's some merit to that. A lot of people are talking about how to use software CM methods over in the hardware world. Actually, I think we did an episode and we had a chat with Oleg about that.
Yes, we did.
But that's another point to remember. And I think, one of the things we're getting at in an episode like this is what are the components that you need to think about if you're making a software digital twin? And CM is definitely one of them, right? And you're often going to find those configuration management mechanisms in that ALM system, in that DevOps system, or the combination of the two. But you may also have to think about the CM of the underlying components too, right? So it gets meta again. What's the version of the emulator you're using, right? So your digital twin sometimes is that emulator, but you got to think about that too. Is it the right one to represent the physical so that you're testing your new version of your software against the right version of the emulator of the hardware? Anyway, there's a lot to unpack there, but I think configuration management is an important one.
Sure. Well, it's funny. It helps clarify something. I have one of my cousin works for in the Air Force for a government contractor, and they do project support. But her job is configuration management, and she talks about how she has to deliver packages a lot, and and when there's a big package to deliver, there's a lot. She talks about how much details to go into it, and so when you think about all the programming and software development that they're doing, and then compiling, and then she's got to pull all the versions, like you said, the right version into the right package. For Air Force projects, it's a much bigger process. So, as we're simplifying a lot of these examples, but as the projects get more complex, you can see where there's a big difference between an A version and a B version. So
absolutely right, and it's sort of the stakes get higher as it rolls up, right? Down at the lowest levels, it's it's new version, old version, little update, that kind of thing. But then when you start talking about these interdependencies of like, well, that won't work if it doesn't have the right version of that, and this can't connect to that, and it gets complicated and it turns into a big deal fast when, you mentioned Air Force, right? It does make me think some of the first places that software showed up in what used to be hardware-only products were planes and this concept of fly-by-wire. Right? What does fly-by-wire mean? Well, really what fly-by-wire means is software is now in control, right? Oh. I tell the computer certain things, it makes some behaviors and some decisions and some outputs, and it sends the message of how to move the flaps and what to do with the engine by signal instead of by physical, it's not cables controlling things anymore. It's wires and electrical signals. And when that's the case, now getting the right versions of things is critical. It's a matter of life and death.
It is a matter of life and death. Fascinating. Okay. Well, I think we tackled quite a bit of topics here today on the software digital twin episode.
Did we tackle the right ones?
I don't know. Well, I would love to hear from folks about that. So please let us know what we missed, and if we should do another episode on it. And if you have some good ideas, we'd love to hear them, especially in some applications that we might have overlooked.
Yeah.
So,
do you want to take a stab at like what did we really cover? I've got a thought about it. If you're willing to entertain my view of the summary.
Sure. Yeah, I have some ideas too, but I'll summarize with some of my thoughts.
Okay. I think what we talked about is what is a software digital twin? It's a little bit of a messes with your head, but It's an emulation. It's a representation of the software, or it's a way to try it out. And it's helpful to think about it in two buckets, even though they're not different buckets. It's a spectrum of things. But you can think about software for software's sake, where the hardware is just the place it runs, right? But the purpose and the interactions and all that is primarily about the software. And the other bucket is when the software is a component of a physical product, and it's the interplay that really is important. And those two make you think about digital twinning a little differently in terms of where do they run, how do they work. But the components that matter are going to be the way to configuration manage and store the software, the way to build the software, sort of the factory, the compilers, those kinds of things. They are going to matter. And then how you emulate all that, what versions of emulation you use. All those things are going to be important to building a digital twin, regardless of which bucket. And then if it's the side where it's a cyber physical thing, then you've also got to think about those interfaces in your twin. Do you digitally represent the physical product and then digitally represent the digital product, and how do you put them together? Even saying it makes me laugh at how hard it is to describe. But I think those are the things that we talked about that people should be thinking about as the components related to software in their digital twin. But what did I miss, Julianne?
I don't think you missed much in your summary. I think what I was thinking, and for me was, as I'm listening to this, I'm doing this whole series. When we started the series, I was thinking, digital twins is, a very specific, and, highly technical, and not that it isn't all those things, but the purposes of it just really kind of expanded, especially in this conversation, if you think with the software, because there are all sorts of types of twins. You're talking about emulating different environments and the needs of, doing the performance testing, doing the user testing, doing the training, doing all of those things. It just really expanded my view on what and where a digital twin fits in. Originally, I was thinking, we're trying to twin a plane, we're trying to twin a wing, but it's really, that's the extreme example of that. But in software, it's a little more amorphous, where we're going to have to kind of do a lot of iterative kind of modeling to make sure that the software works, because we all know what happens when software doesn't work. It's not good. People aren't happy.
Yeah.
And it's almost critical to be doing some level of digital twin modeling in software to ensure your customer satisfaction and that the product's going to work the way it is. So that's my big takeaway.
I think it's a reminder. Everything you just said reminds me, and it should be a reminder to all of us, that we in the physical product world have a lot to learn from the software world, because I think that people doing software development have probably been doing digital twins for a long time, and we haven't been calling it that, right?
Exactly, yes.
So there's a lot to pay attention to, techniques that we can learn and benefit from.
Right, yeah. And that's a good way to wrap up this episode. So as usual, this was a great conversation, Jonathan. Thank you for helping me pick your brain about software, digital twins, and the digital twin world, really, of software, which my whole view of it shifted in this conversation. So thank you. And everyone, thank you for listening today. And if you have any comments, we're serious. We really want to hear from you. So make a comment on our posts, send us an email. We're happy to chat about this in more detail and possibly schedule another round of discussions on it, because we know that this is a rich area of content. So
even if you're reaching out to tell us why I'm an idiot and I don't know what I'm talking about.
You guys really missed it. Yeah. So please, we'd love to hear from you. And we appreciate your time, and give us a like if you like this episode. And with that, we're going to say, have a great day. And don't forget, got to stay sharp.
Thanks everybody.
Jonathan.
Thanks for being here and listening to this episode of Stay Sharp with Razorleaf. If you like this podcast, please be sure to hit the like button and subscribe to our podcast on your favorite podcast platform, or check us out on YouTube. If you have any questions or you want to leave a comment, please be sure to do that on our post, or send us an email at podcast@razorleaf.com. Until next time, everybody, stay sharp.